Hello, my name is Finn Govers, and for CS50's final project I made a rocket simulation. In this video I'll show exactly what I simulated, how the simulation functions in rough terms, and what the output of the program is. What I simulated is a rocket that launches, gets enough horizontal speed to stay in low Earth orbit, and then slows down to fall back to Earth again. In the simulation I used four forces: gravity, thrust from the rocket, wind force and air resistance. Together with some natural laws, these forces determine how the rocket moves. Thrust is the only force our autopilot program has control over. This is the world. Instead of a vertical and a horizontal axis, I used a rotation axis and a height axis. If you don't know what that means, it's not important. The Earth also has an atmosphere that extends to 24 kilometers in height. Randomly changing wind forces act on the rocket as torque. The autopilot system corrects for these forces by controlling the angle of the thruster on the bottom of the rocket. Each vertical pair of graphs is from a different run. This is the rocket. It has two stages. Each stage has a thruster with a gimbal. The thruster provides thrust and is angled by the gimbal. Both are controlled by the autopilot program. These are the most interesting graphs the simulation can output. You have the path of the rocket, the mass of the rocket through time, the horizontal speed of the rocket, air resistance or drag. The spike at the end is many times higher than the graph limit. In this angle graph you can see where the rocket wants to point and where it is actually pointing. In this period the thrust is shut off, and you can see that the autopilot is no longer pointing the rocket towards its target. This angle graph is for pointing in the other angular direction, which is only interesting in the atmosphere. Its target is 0 the whole time. In the wind force graph you can see the torque on the rocket produced by the wind and the reaction torque produced by the thruster. The autopilot can only know where the rocket is pointing and how fast it's turning, stuff you could measure with a gyroscope, but the outputted corrections almost mirror the wind force. The program can also output a CSV file with the states of the most important variables for every frame of the simulation. This can be viewed in an Excel file. I will now scroll through the code. You can pause to look at the code. Thank you for watching.